So I'm going to talk today about real estate DTP, 10 lessons learned while doing DDD in the real world. I'm going to give you the 10 lessons, then I'm going to talk a whole bunch, and then we're going to go into depth on the 10 lessons. So this is the typical school. You say what you're going to say, then you say it, and then you say what you said. We're going to talk about naming things, talk about local environment, what and how to test, when to ship, easy deployment, flexibility, clear boundaries, remote working, real world limits, and designing well. Let me just briefly talk about, I saw some people taking pictures there. You'll see that slide again, so no worries. Let me briefly talk about me. Like Chuck said, I work for Ingersoll Rand, a huge industrial company, but we have a small division in there called Nexia, where we build software for home automation, smart homes, Internet of Things. It's a lot of fun working with cutting edge software, but also working with hardware, and then I get to dog food it all in my house, which is very cool. Like everyone, we're hiring. If you're interested in home automation, come talk to me. But this talk is not about home automation, and it's not about anything that I did at Nexia. I'll get into that in a minute. So what is a DTP? It's a data transformation pipeline. Is it ETL? Is it pipes and filters? Amazon has a product called DTP. They also have a product called EMR, Elastic Map Reduce. What about Kinesis, Java pipeline, Python pipeline, some other commercial off-the-shelf tool? Maybe you're wondering, is it any of these things or even something else I didn't listen? The answer is no. This is a term that I coined for the work that I'm going to talk about here. My definition of a data transformation pipeline is a custom computation solution that can take disparate data inputs, process them through a defined series of logic steps, and generate a defined standardized output. What is all that? Well, we'll get into that. Why would you use a DTP? Well, in my case, I like to write back-end software way more than front-end software. In a DTP in this, there's no front end. There's no JavaScript, no HTML, no CSS, no client server. It's just data processing. And for those of you that are big into that, this is a dream. But really, what is a DTP? Well, hold tight. I'm going to get to that in a minute. But first, we are here at Explore DDD. I want to touch on a little bit of some of the DDD concepts that came into play here. Vaughn in his book said, use DDD to simplify, not to complicate. And that, for me, is one of the biggest takeaways of the value of DDD, is it creates a mindset when you're thinking about complicated software to try to simplify it in various ways. Those of you that have read Eric's book or Vaughn's book that have been around with DDD for a while, these are some of the concepts that came into play as I built this data transformation pipeline. And so I'll talk more about these throughout the talk as we go. DDD's value to me is in the concrete, not the abstract. You can spend all the time you want modeling things, designing things, whiteboarding, sticky notes. All of those are great things to do. But the end game is to use that to build concrete working software. So let's talk concrete. Let's talk real working software. Introducing French property. So French property is a website that lists properties for sale in France. You can think of Zillow for France, if you will. This is Ingram. He's the founder and owner of French property. Interestingly enough, their corporate offices are based in England. So they're in England, I'm here in the US, but all of the properties that they list are in France. Here's a screenshot of their public website listing all different properties and services they have. They also have multiple microsites for different kinds of properties. This one is for properties that are on a lake or include a lake. And here's a zoom in of a property listing. So pretty standard if you've done anything, if you've bought real estate or searched for real estate, you often use web services like this. Let me tell you a little bit about how I got involved. 4 years ago, I started mentoring Ingram as we did Ruby mentoring and teaching him test-driven development. And that was a great experience. If you want to learn more about mentoring, I'm happy to talk to you afterward. But at the end of about 6 months of mentoring, at the end of 2014, Ingram said to me, you know, I really need some help with my software here. It's the typical big ball of mud. It's a big old code mess. His software, which is designed to pull in real estate data, would take a whole day to process his feeds. And he was starting to realize for some of his feeds where there was a significant number of properties for sale, if he wanted to run the feed processing on a daily basis, some of them were taking more than 24 hours. So that's not gonna work. What are we gonna do about that? Well, here I am, I can fix it. So we decided to dive in and do the rewrite of the data processing part of French property. So the first thing that you do in any successful software enterprise, particularly with the DDD mindset, is spend some time with design. Now this isn't big upfront design. We're not trying to work out all the kinks and all the nuances, but you do story mapping, you do process flows, you figure out your dependencies, you understand your context, you understand your boundaries. As much of this as you can do so that when you start to model your system, you're modeling from as much knowledge as you have. So we spent some time, and a lot of this was remote. Ingram and his team did some design work, and I would screencast from here in the States. They did some story mapping, the proverbial sticky notes. You can see a lot of this that they did, talking about different process flows. I don't know if I showed that. Yeah, I think that's a later picture. And so we came up with an initial concept. Drum roll, microservices. So our first commit in December 8th, 2014 was a big README file, okay? And I'm not gonna read this to you guys. You don't have to read it. I'm gonna explain it to you. To me, this is the best way to start software. You don't start with committing code. You commit your brain dump of that design session. This was the vision of what we wanted to do. And this was the vision in a picture. How do you have a whole bunch of disparate data sources come into some kind of pipeline? So agency feeds, and by agency, like a real estate agency, would come into this pipeline. Lots of processing steps. And this is not just pipes and filters. This is not, this data gets transformed a little bit, gets transformed a little bit. All kinds of different business rules might happen here. Lots of cloud integrations. We need to talk to things. We need to receive data from things. And ultimately, at the end, spit out the French property standard JSON format. Because their website is dealing with a data set that they need cleansed. So effectively, we want to end up with a bunch of data in a database for their website that's searchable, that's all standard format, that has been basically normalized and cleansed from this input. So this was the goal. We started with 9 microservices. Each of these was designed to do one thing. The determiner would determine what kind of data feed we had. The job checker would check whether or not we needed to even process that given feed. Maybe it hadn't changed, so we didn't need to. The downloader would download the feed. The parser would parse the data in whatever format it is. The splitter would split it into potentially multiple batches so we could have some parallelism there. The status checker could check on a given property level whether that property had changed. Maybe it hadn't changed, we don't need to process it. The mapper would map all of the data fields from the feed into our standard schema. The translator would do language translation. This is France, after all, so we want to have all of the data in French as well as English. The image handler would handle all of the images for the properties. and then the storage service would store it all. The determiner we had multiple determiners we realized. Sometimes we want to check hourly and check an MD5 checksum. Other times we might want to check every 5 minutes and maybe just have an HTTP header response. Did the feed change? So this sounds easy, right? The original stack that we built this in used these services. Iron.io, which is a great cloud service for workers, data caching, and queues. Exavault is a cloud service for FTP, secure FTP storage. Mongo Lab has a cloud MongoDB. Heroku is a cloud service for basically running web services and other kind of services. Elephant SQL is a Postgres in the cloud. And then I'm a Rubyist. That's what I love to do. So we write it in Ruby, and RSpec and Cucumber are two testing libraries for Ruby. But then we had a great idea. As we were just getting started with this, we thought, well, what if we did this serverless as a multi-worker process? Oh yeah, Chuck Norris seal of approval. So let's get rid of a Heroku. Let's get rid of Postgres. And while we're at it, we got rid of Cucumber. I could talk about that later, but it didn't add any value above and beyond RSpec for testing. And along the way, let's add in a few more cloud services. So here's some of the services. Ruby in the middle, because this is all built in Ruby. I already talked about Mongo Lab. We added Cloudinary for images, Google Translate, Docker, some of the Iron services, Mailgun, which is a cloud service for email. The project was fully run via GitHub and Trello, and using Amazon SQS. So finally, what a DTP really is. Now I've set the background. Let me explain what this data transformation pipeline means to me in the context of this project. So this is the big diagram of the data transformation pipeline for French property. There are 4 pieces to it: the downloader, the processor, the purger, and the reloader. I'm going to zoom in on each of these. So let's talk about the downloader first. This is the downloading part of the pipeline. And you can see why I chose the term pipeline here. Other than that it angles so that it fits on the slide, this looks exactly like a long pipeline of a series of steps. So the downloader takes an XML feed from one of the agencies, does some encoding cleanup. We realized we have no guarantee of whether it's UTF-8, might be some other kind of encoding. And so we'll clean that up. We'll archive the feed to Exavault. And that's important because if there's a problem and we don't know it for a day or two, and we go back to try to troubleshoot the problem, their feed may have changed. So we want a copy at that moment it ran. We'll pull out all the references for the properties. Then we'll split the feed into batches. Now I'll talk more about this in a little bit, one of the lessons learned, but originally we didn't do the splitting. And last, well then we enqueue a purge worker. So the purge starter is an object that is designed to enqueue the worker to handle the purging step. And then each of those batches runs through its own pipeline, parses the data, collapses certain parts of the data that they might, some XML feeds had attribute trees that were very deep, and so we had a step that could collapse those. The expander we also had the flip side of that where we needed to sometimes take certain XML attributes and expand them into a collection of attributes. Normalize them. We want to make sure that all of our types are consistent. So if we're expecting a postal code to be a string, if it's 01234, we want to make sure it's a string and doesn't turn into the number 1234, for example. Converter. Sometimes we needed to convert types to make sure that there's consistency. The deduper, we would remove duplication. The collector was designed to take attributes. You might say, I have a property near a lake and it has mountain views and it has lake views and it has a ski lift on it. So I might want those 3 tags collected into a features collection. And then all of that transformation data is put into the processing starter, which starts another DTP. Let's look at that one. That's the second pipeline, that's the processor. So the batch processor pipeline, again, very similar architecture. It's a series of steps. Now we're taking that data from the downloader DTP, and that data has been cleansed, but now we need to do a bunch of business processing on it. So first we pull that out of the cache. Then we do a geolocation lookup because we want to know the property. We might just have a street address, or we might have, maybe it's just a postal code, and we want to be able to geographically locate it in France. We upload all the images to Cloudinary with a lot of logic so that we're not constantly uploading images. Maybe if the image hasn't changed since the last time we processed this property, we don't want to re-upload it. We evaluate the property for significant changes. It turns out there was some business rules where French property wanted to know if a particular property's price had changed by more than 10%, that should flag something as this is significantly changed. So an attribute on the property, this has really changed, we want to pay attention to that. The populator would populate certain data fields. If maybe the property didn't have a title field, we can pull that out of the description and just truncate it. The detector would do language detection. So we used Google Translate, as you saw on the earlier slide. We could detect languages so that if the feed had French and English in it, we didn't need to translate. No need to pay the cost of a cloud service if you don't need it. And then the creator would take all of that cleansed data and put it into Mongo so that we would have a data record. And last, enqueue it into our data queue. Because you remember that earlier slide of the pipeline, the goal is to have the output so that the website can have that data. So the output was a JSON data blob formatted into a schema which we controlled. And then when we're done, we would release that queue from the cache. And that was an important step because if something went wrong, the whole process could be redone. It was idempotent start to beginning. So if it crashed partway through, Ironworker could rerun it and it would just pull that same data out of the cache and try again. And last, it would report, it would send out a report via email. Those are the 2 big pieces of the pipeline. Let me briefly touch on number 3 and number 4. So number 3 was purging. And this is if you run a feed that has 100 properties today, and then tomorrow you run it and it has 90 properties, there are 10 properties that need to be cleared out. Those 10 properties aren't in the feed anymore. So the purger would pull the data from the cache and it would remove the images from Cloudinary, remove the data record for those 10 properties from the database, and emit delete messages to the queue so that the rest of the upstream system could know, oh, those 10 properties have been removed. We don't need to show them on the website anymore. And last, the reloader. This was a pipeline that came up much later in development where we realized there are times when as the system was evolving, we might need to clear out the upstream data and reload what we have. Not rerun the feeds, just take what's in the Mongo database and push it through as if we had processed it. So that's what the reloader does. Very simply, it literally enqueues multiple parallel processors to go through the database, pull all the records, and then inject them into the data queue as if they had just been processed. So let me talk about some of the specific wins from doing this. Eric Evans said, there will be big rewards for small, loosely coupled modules. Let's see, where did I hear that? Oh yeah, I think he said that last night in his keynote. So it's true, there are big rewards for small, loosely coupled modules. They don't have to be completely separate in microservices. In this case, each module is its own contained class. So some specific wins by building a DTP, a data transformation pipeline. Refactoring is easy. Each of those steps is self-contained. Its boundaries between the steps are clearly defined. Its interface is clearly defined. It's a common interface for all of them, but there's a lot of flexibility. So as we evolved the software, it was actually quite easy to refactor certain pieces to say, oh, we need to change the logic of how the splitter works. Okay, here's my one class. I can look at that class and I can handle it there and not worry about its impact on the rest of the system. Testing was easy. Every single step has a set of unit tests, and those tests are very clear and easy to read because the interface for each of those steps is so clear and simple. Each of those large bounded contexts, the 4 pipelines that you saw, are also easy to test from an integration standpoint because the data flow makes sense. I can say, I'm going to start with this mocked up input, run it through the system. All I have to do is stub out my external services. I don't want to call Cloudinary every time I run my tests, for example, but expect a certain output on the other end. So the inputs and outputs are easily testable in that regard. Changing the pipeline is easy. Because it's not like a Unix pipe where I'm expecting a very certain data output on each side, I can add new steps wherever I want, and those steps can do whatever it wants. The data that's moving through the system is changeable in a way that makes sense. For example, that evaluator step I alluded to earlier, we didn't have that at first. And then the business said, well, wait a minute, I want to know if this property has significantly changed. Okay, add an evaluator step, plumb it right in, let it do its thing with the data set, and we're good to go. No need for servers. For the first time ever, I wrote software that I don't have to configure a server. I didn't have to do Heroku. I didn't have to do Amazon and configure a circuit. I didn't have to do any of what I used to do every time I did any software project. Oh, I gotta install, do kernel upgrades, all of that sort of thing. None of that. There was no need for microservices here. All of the steps are running within their own worker, and the workers are autonomous between each other. They share data via the iron cache, but really that's just a way to say, this worker's done, here's its data that the next worker needs. So there was no API that needed to be written. The contexts are separate. As I said, the downloader DTP and the processor DTP are fully separate. So if I change one of them, there's no effect on the other. The boundaries are clear and simple. One of the patterns that got used a lot that I'll talk about in a minute is the repository pattern, building anti-corruption layers between the cloud services. Having those boundaries defined cleanly was a godsend because it made it so easy to code against cloud services, but also change cloud services as needed. This is basically, I just said, the repository and the anti-corruption layer allowed for a clean integration. And this pattern is language agnostic. I built it all in Ruby because that's what I'm good at and what I love to code in, but there's nothing Ruby specific about this. It's performant. Ruby tends to get a bad rap these days as it's not very performant. This thing was hugely performant compared to the big ball of mud that was before it. In short, this was a huge win building this data transformation pipeline. Yeah?
How did the downstream processes know it was their turn to pick up something from Iron Cache? Was Iron Cache basically just a queue? Did it do some sort of notification?
So the question is, how did the downstream processes know that it was their turn to run? There's a starter class at the end of each. So like at the end of the downloader, it has a purge starter and a processing starter. And those are steps just like everything else. And its job is to take what was done, enqueue the next worker, and give it the data set that it needs. Okay? So let me talk about real world wins doing this. System changes are fast. Just about 2 months ago, we ran into some real world limits with IronQ, where IronQ has a max size to messages in the queue. I believe it was 40K, and we were running into some properties that had so much descriptive data, they were larger than 40K. Well, we talked about it and we said, let's switch to Amazon SQS. How hard can it be to switch one queuing system to another? 4 hours. 4 hours from discussion to push it to production. One of the feeds they had over 15,000 properties in it. Now, their old system couldn't handle this. I talked about how they would run a daily import. That 15,000 properties would take more than 24 hours. So they had that agency give them I think it was 8,000 or maybe 9,000 special feed. That was the max they could process. We ran the 15,000 through this DTP in less than an hour. Evolving the software became very easy. I talked already about how we added the evaluator. The populator was a step. We realized some feeds didn't have titles of their properties, so added a step to pull the data out of the description and put it into the title. The translator. The translator originally was one step, and we realized actually it makes more sense to do a detector so we can know what languages we have, and then we can do some mapping to say, oh, actually this feed has French already in it, so I'm now going to translate French to English. Or this particular feed had English and French, I don't need to do anything. Correcting real-world issues easily. We hit a lot of cloud services limits, and this taught me so much about when you're building real-world software and you get started, there's a utopia of services out there, but when you actually start to code against them, you will hit all kinds of edge cases. We hit memory limits. I mentioned earlier we had to implement a splitter and run the property feeds in batches because Ruby does take up a fair amount of memory when it's running. It's an interpreted language. And we were hitting the memory limits of the ironworkers, which would cause the ironworkers to crash. Well, okay, let's parallelize that. Iron is excellent at that. Let's spin up for a given feed, instead of running one worker to process it, let's run 50 workers simultaneously to process each of them 1/50th of the feed. We also had to deal with bad data. One of my favorite examples is one of the feeds, their postal code, they had incorrectly put a date of when the feed had changed there. So it was a string of what looked like a date. Well, Ruby, in parsing that XML, tried to be smart and say, oh, this looks like a date. I'm going to create a date object. Well, a date object is not really like a string object, and we ran into some interesting bugs there. There is no bad coupling here. The system was a black box to the rest of the French property ecosystem, and rightfully so. French property should say, I just want to define some feeds, throw them over the wall at this DTP engine, and on the outside of it, on the other end of it, I want JSON objects in my queue that are standardized and that have been processed and that all of their attributes have been pushed to the right cloud services. So there was no coupling to any other systems. And last, this is cheap to run. The costs for running these services are in the tens of dollars or hundreds of dollars a month. This was not thousands and tens and hundreds of thousands of dollars to run this DTP. Yes, a lot of big wins. So let's look at some code. But first, you might ask, what about tests? I've given some talks in the past. I'm a big proponent of testing, and I try to do TDD as much as I can. I loved writing tests for this system because it was so clean. Here's an actual run I did about 3 days ago of the system, and you can see there were almost 1,000 tests, and they ran in just under 9 seconds. So coding against the DTP allows me to do the TDD dance, where I can work on a test, run it, make changes, refactor, and move back and forth between tests and code very quickly. Another huge win. Okay, so I'm going to just show you a little bit of code for a minute. I'm not going to go too deep in this, but I wanted to highlight a couple things. This is the directory structure. Hopefully, is that big enough? Can people see that? I can bigify it even more. Is that a little bit better? Cool. You can see that the naming is very consistent. You have the checker, the downloader, the processor, the purger, the reloader. These are my bounded context. These are the DTPs when I showed that big diagram. So the downloader, the first one I showed, there's all my steps. You can see each of those steps by name, the archiver, the collapser, the converter, the deduper. Each of these is its own file, it's its own class. It's a well-defined step. I also have a directory of repositories. This is where I define all of my repositories. An archive repository, that wraps Exavault. The cache repository wraps Iron Cache. Cloud repository is the base class that they all depend on. Data repository wraps Mongo. Image repository wraps Cloudinary. Now you notice I don't say Cloudinary repository there because I'm not binding myself to Cloudinary. This class is designed, according to the repository pattern, to abstract all of that so that I can have each of these deals with a given service but isn't bound to a particular provider of that service. And let me just show you as a quick example. Here's what the archiver looks like. We'll collapse this down. You can see that this archiver, even if you don't understand Ruby, this should be pretty easy to follow. It inherits from a base step class. Every one of these steps in the pipeline had some commonality, which was its defined public interface and certain things that I added about logging and reporting that made it very nice by having it all depend on, or all inherit from a base class. Here's its public method. It's actually, the public method is execute, which then gets turned into this protected method run. You can see pretty much all the archiver is doing is it's using an archive handler and calling an archive method on it. Gives it the data, and that's all the archiver needs to know about. It doesn't need to know about failures. It doesn't need to know about anything else. It gets returned the URL of where the data has been archived, or nothing if it fails. And it will return that back up the chain to the calling code. This is what the archive repository looks like. There's some configuration code here, but here is the archive method. You can see this one now knows specifically, oh, I'm actually using the net SFTP library, and I'm going to do a block of code to create a directory remotely if it needs to be there. And then I'm going to figure out my file path, and then I'm going to upload the data to be archived, and I'm going to return false or raise an exception if there's an exception, and then I'm going to otherwise return the path of what I've archived. So this is the repository that knows how to talk to Exavault to archive that data. The archiver doesn't know anything about that, and the rest of the system doesn't know anything about that either. That is not what I wanted to do. We will go back to that. Okay. So let me touch on those lessons learned. Naming things. It's hard. So are off by one errors. Ubiquitous language. We all know that term. Eric talked about it last night. It is so important to name things well, but it is also such a challenge. You can see that a lot of my patterns were, I named the steps with ER, the archiver, the downloader, the splitter, naming them after what they do, named by intent, what the class does. But the storager, no, the storage handler, the storage keeper, some of it gets tricky. So these patterns are good, but you also have to be aware that sometimes they will go bad. The uploader, well, what am I uploading? The archive of the feed or the images? Oh, I need an image uploader. Oh, now I need my names to be 2 words. That was one of the challenges with coming up with a good name. The other thing was just language barriers. Originally, Ingram, the product owner, came up with bifurcator. Who knows what bifurcator means? Who actually uses that term? Maybe 1 or 2 of us. Yes, it's a good technical term, but splitter also works too, and splitter seemed to make a little bit more sense as a common term there. Also, I didn't know what the word bespoke meant. I don't know why, but for some reason I didn't. There was a mapper config file called bespoke that the product owner had created, and I thought it was just another agency. I thought, oh, there must be an agency in France called the Bespoke Agency. I didn't realize that that's his miscellaneous one. That's his junk drawer made to order name. Some of these things happen. Now, part of it was because I'm in the US working for a company in England selling properties in France. So some of that's just going to happen. And then lastly, another interesting naming thing, these are properties. When you hear the word property, you might think, oh, like a piece of real estate. Yes, that makes sense. But as a technologist, you might think, oh, like an attribute on a data object. Which of these are? So there was some mental shifts that had to happen when I'm thinking, oh, if I'm storing the real estate data object, is it a property in the database? Or is it a property record that has multiple properties? Lesson number 2, local environment. It is so important to have a good working environment, to be able to, from the beginning, run this whole ecosystem. So what do you run? If it's serverless, how do I do that? How do I run things locally? Docker was a huge win for this. I can just create the same Docker containers locally that are going to run in Iron. And in fact, for deployment, what Iron requires, one way to deploy to Iron is you give them a zip of your Docker, and they will just run that. Processing queuing. It's really hard to have one process running locally and have it in queue the other. I could jump through a bunch of hoops locally, but what I really want is to be able to run the ecosystem as close as I can to how it runs in Iron. Well, it turns out this time, just do it manually. So when I run the downloader DTP, if I'm running it locally, it will output for me the exact code I need to copy and paste to run the processor DTP. I don't have to try to simulate the enqueuing between them locally. Cloud services, this was a challenge. How do you run these locally? How do you run Cloudinary and Exavault and Mongo and all of these services? Well, we came up with the idea of skips. I can define skips as parameters to run the code. I can say skip image uploading. I can say skip archiving, skip reporting, skip translating. And then when I'm running it locally, maybe I'm working on the archiver part of the code. I don't want it to call Google Translate. So I can define these variables at runtime, and it will skip all of those steps. It was also important to understand that we had a pure staging environment. So we had to create, for each of these cloud services, 3 accounts: the production account, the staging account, and then an account that I could use for local testing when I needed to do integration level testing. And the value of that staging environment is that it allows us to do a production-like run, but not worry about it tainting the actual production queues. And last, everything needs to be configured in YAML. No weird configurations. I just want YAML configs for all of my cloud services. Lesson number 3, how to test. I talked a little bit about this. Lots of unit tests. They need to be really fast, but each of these steps were easy to test because they were so well defined and so small. A few integration tests, mostly just happy paths. The value of a staging environment is you can do a lot of testing, live testing via that. And then sometimes test first, other times test after, but always test. The repository pattern really helped in testing these services because I could stub my boundary for unit tests, and then I could stub one level up for integration tests. Lesson number 4, minimum viable product. When to ship. The truth is software is never done. They already had a system, the big ball of mud, so the business decided when to ship. French property goes to events, and so there were certain events where they said, okay, we want to promote our new system on this event. And so we did a beta release, particularly for that agency with 15,000 properties, to show them, oh, we can consume your whole feed now, and in fact, we can consume it in less than an hour. Lesson number 5, easy deployment. This was a goal for me working on this project. I want to be able to deploy with one command, rake deploy. That's it. And I want to deploy to production, rake deploy production. No complicated, nothing like that. This is the value of me working on this as a solo developer. The deploys must be clean. I'm okay if it takes 2 to 3 minutes, but every time I deploy, it rebuilds all my gems and it rebuilds my Docker image so that I know that that deploy doesn't have any taintedness from previous deploys. And they must be easily undoable. I should be able to back out a deploy. Iron.io supports this. You can actually choose to run via previous code commits, which is pretty nice. Here's a run of a deploy. Actually, I'll show that. That's the output of the deploy. And I'll zoom in just to show. I rebuild the bundle, create my package, upload it, and it takes about 2 minutes to do that. Lesson 6, flexibility. The code must be fluid. A well-designed system like this DTP allows for easy changes of pieces without worrying about regressions across the system. The services where you define each object and say this is a service that's going to do its one thing and it's going to do it well, make it easy to, or make the system more flexible. Business trumps tech. Sometimes you just got to deal with business needs, and a flexible system is going to allow you to deal with it quickly. Code limitations. Sometimes you're going to have code limitations that influence the business. That can happen as well. And again, a flexible system allows for conversations with the stakeholders about which way you proceed. Sometimes you do workarounds. We had one case where the schema needed to be an array of data, but we already had a bunch of data in the database. So I said, okay, well, let's just, before we put it into the final queue, let's convert it to an array. That worked for a while until we ran into other edge cases. And so sometimes you make choices where you say, this is going to work to get us through. Other times you say, no, we need to go back and actually change our schema at an earlier step. And then another thing that was really useful is we defined different tags for our GitHub issues, whether to defer something or declare it as low priority or high priority. That really helped. Number 7, clear boundaries. Bounded contexts and aggregates are probably the single most important design concept from DDD that I adopted here. Really thinking about not only the individual 4 DTPs, but each step within them. I want those to be clearly defined context, and I want to know its boundaries. And then as it integrates with third-party systems and cloud services, I want to know those boundaries. Leaky abstractions and high coupling is probably, in my opinion, the source of 90% of software maintenance, where you have those boundaries are not clear, and things are reaching across those boundaries, and your abstractions are not clear. So define very clear interfaces, and use the repository pattern a lot. Lesson number 8, remote works. As I said at the beginning, I didn't do this for Nexia, my full-time job. This was a side job that I started 3 years ago from mentoring this guy. I'm physically remote. The time zone was remote, a 7-hour shift. It was part-time, nights and weekends. And yet, amazing working software is possible this way. I went back and looked at the hours that I'd logged from December 14th until when we launched in February. About 600 hours. Doing the math, if this had been a full-time job, that was less than 4 months from initial concept to launch. Lesson number 9, real-world limits. I talked about some of these before, so I'll run through some of these pretty quickly, but we ran into limits, and you have to pivot, you have to adjust. We hit memory limits. We hit timeouts. We discovered one of our HTTP libraries that I was using didn't have a timeout by default. Well, we didn't know if we hit an agency website and their website is poorly built and it just sits there, eventually the iron worker is going to time out. So we had to handle that. Cloudinary had image limits. IronQ had a data limit. We switched to SQS. Parameters limit. Google Translate. We didn't know this. We thought it's Google. No, they have limits. Limits for how fast you can request and how much data you can request. And then weird crashes, bad data. I talked about postal code, nil prices. How do you deal with that? All of these things are what building software in the real world is about. And lesson number 10, design well. If I had one takeaway from this, that DDD is awesome as a set of concepts for designing great software. But don't be afraid to alter the design. The models, as you discover them, will evolve over time. In May, we changed to a multiprocessor from a single processor. In November of 2016, we changed from having local YAML files to define all our mappings to a service. French Property built their own service so that all those config files could be managed themselves. And then in August, as I said, we switched from Iron Q to Amazon SQS. Designing classes as small and readable is important. Keep the code readable. You saw some of the code. I interspersed comments there. Even though I'm the only person writing this code, my future self will thank me so that I can look at that and say, oh, that's what I meant 2 years ago. So we talked about all of these 10 lessons. I think some of you want to take a picture. You're more than welcome to do that again. This has been a fun project. It was a side project that succeeded in beyond my wildest dreams. It was really fun to write this code. It continues to be fun. I continue to support the software as Lakes France evolves over time. So thank you.
We have about 2 minutes, so time for 1 or 2 questions.
Yes.
So we do something similar where I work.
Actually, wait. Can you hold it 1 sec? We have a mic, I think. They're going to record the questions.
So I was just saying, we do something similar, and I find what really stings us is changes in the input feeds. Once you get a lot of input feeds, if they're significant, the change will stall the pipeline or it'll produce invalid output. Did you have that problem? How did you handle it?
Yes, really great question. Yes, changes in the input feeds. Part of it was designing those initial steps that would take an input feed through about 5 different transformations. So the first thing is well, I don't know if it's the first thing, but it would take all of the data attributes and normalize them. So if we thought, oh, this is supposed to be a string, let's actually make it a string. If this is supposed to be true or false and it has the word true in it, or oui, because it might be French, we're going to make that into a Boolean. What we found is by defining those as each step, rather than this one class is designed to do all of that, each step is doing one little part of that, it made it easier to then expand each step as we needed. Oh, let's cover this corner case, or let's deal with this. The other thing we did is we built a mapping rule based in YAML to say this is how we're going to map what this given feed gives us to the next thing that we need in the pipeline. And so we ended up with a whole collection of YAML files, but this YAML file is for this agency based on a template that maybe the agency follows, maybe not. So it allowed us to start with, we think this agency, which is using software XYZ, follows these rules, but if they've violated in these 3 places, we can override and account for those. And it's worked well. There's hundreds of different agencies that they're processing now that are all sorts of, including XML, CSV, and JSON. Yeah.
Unfortunately, we've run toward the end of our time. I do want to remind you that there is a survey feedback form on the website. I'm sure Dan would love to hear what you thought of his talk. Can we give Dan another round of applause, please?
Thank you. Yeah, definitely come up and talk to me if you want to learn more about this, or even just about the kind of work that I do on the side. Thank you.